Hello friends, welcome to Catalyst Chemistry. This is almost last part in the alcohol, phenols and ether, that is what physical property. The next one is what chemical property. Okay, in physical property, carbon oxygen bond is a polar bond is there, that is having a what net dipole moment. The ether is having a what net dipole moment, bear in mind. Next, after that, ether, lower member ethers are soluble in what water because of what hydrogen bonding. Okay, that is most important compared to alcohol and ether. Okay, that is what most important. Alcohol means what, in that case also what hydrogen bonding possible, in this case also what hydrogen bonding possible. Okay, that is most important, means lower ethers are soluble in water, soluble in water due to hydrogen bonding. The next, after that, what structure of ethers is there. Just here CH3O CH3 is there. This is oxygen is having a 2 lone pair of electrons. Okay, 2 lone pair means how many, totally how many electrons are there? 4 electron. Pair means what? 2 pair. What is the hybridization of this one? sp3 hybridization. You have to apply that is trick. Number of what is that? Sigma bond. Next, after that, what? Lone pair. 2 sigma 2 lone pair, that is equal to 4. 4 means 100% sp3 hybridization, case closed. Okay. Next, after that, carbon oxygen bond length is there 144 picometer. In this case, bond angle is what? 117.7 degree. Because of actually in this case what happen, the important point is what, tetrahedral is there. No, tetrahedral bond angle is what? 109 degree 28 minutes, but in this case the bond angle is greater because of, in this case what happen, the bond pair repulsion. If the bond pair repulsion takes place compared to what lone pair, automatically the bond angle is going to increases. That is the most important point, bear in mind. Okay, which repulsion is there? Bond pair repulsion. Here bond is there, no, here bond is there, no. In this case what happens, the repulsion is more. If the repulsion is more, automatically the bond is going to what? Increases. In this case lone pair repulsion is a less compared to what? Bond pair repulsion. Important. That's why what is the geometry of this one? Geometry is a tetrahedral. What about a shape? It is a look like a V shape. How are you going to think about it? It is a look like a V shape. Here is there, no, like this. This how to write like this? No problem. That's why it is a look like a V shape. Next, after that, heading is what? Chemical property. This is important for entrance exam, particularly for NEET and JEE exam, also what Karnataka CET. I think this question is asked in what? CET 2006. Okay, I think almost forgotten. This question is important. Okay, 2016 question CET. Here is their chemical property, cleavage of carbon oxygen bond in ether. This is most important, no? Cleavage of carbon oxygen bond, reaction with HX. HX means what? Hydrogen halide. That may be HI, HBr or HCl. Oh, don't take HF. HF is a very strong bond is there, hydrofluoric acid. Okay, just here in this case ether is there, and this can react with HX to form alkyl halide plus release of alcohol. This is important. These are general reaction. I will explain later. Okay. Here is there what? This is a methoxybenzene you called, if R is replaced by CH3. R means what? CH3 only, no? Methoxybenzene is there, or anisole. The word is important. In 2020 NEET exam they used the word anisole. They don't use the word methoxybenzene. Both the IPC nomenclature and common name both are important. Okay. This is what anisole can react with the HX. Obviously, in this case, this cleavage takes place. Don't cleavage this one. Okay. Finally, there is a formation of product is a phenol plus release of what? That is RX. Okay, alkyl halide. Okay. Next, just here NEET 2017 and 2020, the question is same, almost same. Okay. In NEET 2020, they are given words. Okay. Just here in this case, what is the name of this one? Anisole. In this case, what happened? Here is oxygen carbon bond is there. Here is what? Carbon oxygen. This carbon is a aliphatic carbon, this carbon is the aromatic carbon. Okay, in this case, this cleavage is a difficult. This cleavage is a difficult. Next question, why this cleavage is a difficult? Very simple. Oxygen having a what? Lone pair of electron. These lone pair of electron donate towards aromatic benzene ring. There is a possibility of formation double bond character. If double bond character is there, that is very difficult to break. That's why this cleavage is easy. This cleavage is what? Possible. Because of, in this case, this lone pair of electron do not move towards this CH3. Why? Again question, because this benzene ring is act as an electron withdrawing group. benzene ring is act as electron withdrawing group, automatically these electron come towards a benzene ring, there is a formation of possibly double bond character. One more, in this case what, there is a resonance also possible slightly. After that, in this case what, this HI is there, hydrogen iodide. HI means iodine is a good leaving group, that is why they are going to use what, iodine compared to what, HBr and HCl. After that, they are going to maintain a cold condition, means there is a formation of product is what, phenol plus release of what, CS3I. In this case just you have to break this one, CS3I can mix up with this iodine, hydrogen is going to attack on in this case. Okay, there is a formation of phenol. This is most important question, bear in mind. Okay, next after that, in this case these two also important. Here RO, R dash you have to take, otherwise you have to take R only. Ether can react with the hydrogen iodide. This lone pair attack on this hydrogen, automatically what happen, iodine will go out. This is a almost equilibrium reaction. There is a formation of intermediate product. This oxygen is going to get a what, positive charge because of the loss of valency. After that, just here in this case iodine will go out, that iodine can attack reverse, it is a look like a SN2 type. They are going to ask you in examination what type of reaction is it, means that time you have to write SN2. Option they will provide SN1, SN2, E1, E2, such kind of options are there. Okay, in that time you have to select SN2 is the right answer, because just here in this case this nucleophile is going to attack on back side, automatically what happen, in this case cleavage takes place. This R can react with iodine to release of Ri plus release of what, alcohol, that is what, ROH. This is SN2 pathway. Because of, in this case you know very well about that, that is what, primary carbocation is possible, no, just here in this case. Okay, next after that, this question is important, this question is asked in what, CET 2016. Just here in this case what, CS3, CS3 is there. In this case which cleavage takes place, this first one or second one cleavage, this is the first, this is the second. This cleavage is not possible. It is a possible, but that is not a more stable. If it is possible, that is not a more stable. This cleavage is a more stable, because of, if you are going to cleavage this one, you are going to get this structure CS3. Next after that what, this is a CS3 is there, here is what, CS3 is there. In this case we are going to get a positive charge. This is a tertiary carbocation. The tertiary carbocation is a more stable because of hyperconjugative effect. This question is also most important point. Okay, this question is also asked in what, NEET 2020. Okay, that is why most important. This cleavage is possible. Obviously in this case iodine is going to attack on what, this carbon, because of iodine is act as a nucleophile, no, the nucleophile is going to attack on this 100%. This is a which pathway, this is SN1 pathway, you know very well about that SN1 and SN2 reaction in haloalkanes and halorine. Okay, that is why the most important, they are going to ask you what in second time. In second time they are going to ask you what pathway follow this reaction, that time the option is what, SN1. Which what about this one, this is SN2 pathway. Okay, bear in mind friends, this is a cold condition is there, bear in mind. Okay, after that there is a formation of CH3OH and this is called what, final product. Okay friends, you have to take screenshot. The next last part is there, some of the electrophilic substitution reaction is there, I will explain now only. Okay, you have to take screenshot. Okay. Okay friends, the next, this is what, second one, electrophilic substitution reactions. Okay, the first one is reaction with what, HX is there, no, in that what chemical property is the first point, this is the second point. Electrophilic substitution reaction, electrophile means you know about that, that is what, electron deficient center. Just here alkoxy group is there, this OR indicate, OR means what, CS3O, that is alkoxy group, ortho and para directing group, and activate aromatic ring towards electrophilic substitution reaction. Okay, that is important point. Okay, all these things we discussed so far. Okay, this is what, anisole, bear in mind important naming, anisole, methoxybenzene, methylphenyl ether. Okay, all the names are important, all the names are different, but in this case what, this is anisole is an important point. Okay, why it is an important point, because directly entrance exam they are going to ask you anisole, but you have to know the structure, no, anisole, then only you are going to solve the question, otherwise it won't be solved. Okay, in this case what, 4 reactions are there, I wrote here 2 reactions, after that I will explain 2 reactions. The first one is Br2 in CS2, ethanoic acid halogenation. This Br2 in CS2 what, this point also discussed in what, alcohol phenols also. Okay, particularly this is ether is there. Okay, halogenation is there. In this case Br is going to attack on what, ortho para directing. Here only I explained ortho and para directing group is there. Here point is ortho, this one is what, para. This is a minor due to steric hindrance, this is a major due to less in this case what, less steric hindrance, in this case more steric hindrance. Okay, means almost in this case steric hindrance is negligible. Orthobromoanisole is there, parabromoanisole is there. This is the first one. This question is asked 2 to 3 times in PO, bear in mind. Okay. After that, next constant HNO3, constant H2SO4, there is a generation of electrophile, that is what NO2 plus is electrophile is going to generate. Orthonitroanisole is possible, paranitroanisole is possible, one is minor, another one is major. Okay, these two are reactions. You have to take screenshot. I will start next Puddle-Craft alkylation, Puddle-Craft acylation. Okay. Okay friends, the next reaction, just see here, this is what anisole, starting material is the same. In this case, they are going to add a CH3COCl. After that, they are going to add anhydrous AlCl3. Okay, this is indicate Puddle-Craft acylation. This one is Puddle-Craft alkylation. Alkylation is different, acylation is different. Okay. After that, in this case, CH3CO is act as an electrophile. That electrophile is going to attack on what this anisole at the ortho position first. 2-methoxyacetophenone is a possible. This is a what minor product. After that, in this case, 4-methoxy here is there. You have to start from here 1, 2, 3, 4. This is a 4-methoxyacetophenone. When you are going to write a 4, 2, 1, so on, that is indicate what IPAC nomenclature. Just here in this case, 2-methoxy here is there. This is a major role. COCH3 is important. This is a 1, this is a 2. 2-methoxy. This total group is indicate what acetophenone. Acetophenone means here is there no C double bond O CH3 means both are same. CO I wrote C double bond O. Okay, both are same. That's why this is structure is acetophenone. Okay. Next, after that, they are going to add a CH3Cl. After that, carbon sulfide. That carbon sulfide is going to block the positions. I discussed all the things. Okay, most important in what haloalkanes, halorine also. What is the role of this Br2? Why they are going to add a CS carbon sulfide? Okay, all these things. And ClCl3. This Puddle-Craft alkylation. CH3Cl. This CH3COCl. Okay. After that, in this case, 2-methoxytoluene is possible. 2-methoxy means here is 1, this is what 2, 2-methoxy, they are going to consider 2-methoxytoluene, in this case what 4-methoxytoluene. This is a minor product, this is a major product. Okay, all the reactions are important, make it practice. Up to this what alcohol, phenol, ether topic completed. Okay, two topics are completed, one is haloalkanes, another one is alcohol, phenol, ethers. Okay friends, thank you, subscribe and promote the channel, also share. Thank you.